Hi everyone, this is section 1.4, which is called Solving Absolute Value Equations. And this is the second section in chapter 1 that we're going to cover. And again, it's going to cover a little bit of material that maybe you've heard a little bit about before, and then have a couple extensions as far as the Algebra 2 connections. So the first thing we have to tackle is to answer the question, what is absolute value? And I think you've heard of absolute value before. It's a number or a variable that is in a symbol that looks like this. Like I might write the absolute value of -2. So these bars that are around the value of -2 are considered to be the absolute value symbols. And some of you might be thinking, well, I know the answer to that. That's 2. So a definition that you might have learned in Algebra 1 is that absolute value is the distance a number is from 0 on the number line. And distance is always considered to be a positive number. So when we take the absolute value of a number, whether it's positive or negative, it's always going to be the positive value. So to visualize, if this is 0, this is -2, and this is +2, the distance from here to here is 2 units, and the distance from here to here is also 2 units. So the absolute value idea, how far a number is from 0 on the number line, tells us that whether we're to the left of 0 or to the right of 0, that answer is always going to be positive. We're going to look at a little bit more of a formal definition this year, and that definition is going to be more algebraic in sense. This is the Algebra 2 definition. The absolute value of x is equal to the following. It's equal to x if x is greater than or equal to 0, and it's equal to the opposite of x if x is less than 0. So what this says to us is the following. Say my value for x is 5. If I take the absolute value of 5, 5 is a number that's larger than 0, so it falls into the top part of this definition. The absolute value of 5 then is equal to just what the value of x is, which is 5. Now, if my x value is equal to -12, then we would be taking the absolute value of -12, and this value for x is now going to fit the second layer of this definition because x is smaller than 0. So if x is smaller than 0, the definition says that we take the opposite of the number inside the absolute value sign in order to identify the absolute value. So the opposite of -12 is +12. So the same thing that you learned as distance a number is away from 0 on a number line can be written in an algebraic sense. This right here is the definition that I want us to move towards this year and get more comfortable with. We can use absolute value in a bunch of different ways, and the first is going to be through evaluating an expression. An expression is something that doesn't have an equal sign in it, and you can evaluate them by taking a known value for a variable and substituting it in to the expression where that variable exists. So if we need to evaluate this expression of 8.4 minus the absolute value of 2n plus 5, when n is equal to -7.5, we're going to do the following. It becomes 8.4 minus the absolute value of 2 times -7.5 plus 5, close the absolute value sign. When we evaluate, we're going to follow the order of operations. So we're going to work inside the absolute value sign first. It's kind of like though we treat those like parentheses. So this becomes 8.4 minus the absolute value of -15 plus 5 after multiplying there. This in turn is going to lead us to 8.4 minus the absolute value of negative 10, which will lead us to 8.4 minus the absolute value of negative 10 we discovered up above by the definition is positive 10, so this is 8.4 minus 10, and 8.4 minus 10 is negative 1.6. So this evaluation of this expression leads us to negative 1.6. Make sure you understand that. Write down any questions you might have with it, like if you don't know where the variable substitution should be or how we went about evaluating something, so that we can talk about it together in class. The next piece of this, I'm going to just pull my page up, is to move towards absolute value equations. And absolute value equations are going to be exactly that. We're going to have an equal sign in what we work with. Let's see if I can pull this up a little bit more. It's not cooperating with me. This is where the smartboard would be a little bit better. In an absolute value equation, we can say that if the absolute value of A equals B, then we really have two scenarios going on. And those two scenarios are going to come in very, very handy when we actually solve absolute value equations. The first, if we're dealing with the absolute value of A, we know the absolute value of A can be defined in two ways. It's either going to be A if A is greater than or equal to 0, or the opposite of A if A is less than 0. So if the absolute value of A equals B, then we have two scenarios that will hold true. If this matches with the top scenario, the top line here, then we're going to say that strictly A will equal B. If we go along with the bottom part of the definition, then we know that negative A will equal B, or A will equal the opposite of B. I'm going to star this, and I'm going to star this. These are the two that are going to help us solve absolute value equations. So as we go through the next couple examples, we're going to use this idea together in order to find actual solutions. So the first example I'm going to provide to you is the following. It reads, solve the absolute value of 3x minus 2 plus 8 equals 12. Now, solving an absolute value equation starts off exactly using the same mindset as solving a regular equation is. We want to find out what the value for the variable is. We want to make sure that the absolute value is isolated. That means get it by itself. So in this example, we're going to, before we do anything with the two scenarios, is we're going to subtract 8 from both sides. And that leads us to the absolute value of 3x minus 2 is equal to 4. Now, what we went through on the previous screen is that this has two conditions. We can say that A, which is 3x minus 2, can equal B, which is 4, or A, which is 3x minus 2, can equal the opposite of B, which is negative 4. Both of these scenarios are possible, which means we solve both of these equations. So every absolute value equation actually has two equations within it that don't involve the absolute value once you change things around. You're going to solve each of those. I'm going to add 2 to both sides. Give me 3x equals 6, and x will be equal to 2. And then I'm going to do the same with the other equation. I get 3x equals negative 2, and that means x will be equal to negative 2/3. So that it looks like there are two possible solutions to this. We're going to take each of those solutions, and this is the crucial part. You have to go through and check your answers, because there is a possibility that one or both of them will not work. So we're going to take that value of 2 that we got initially here, and we're going to sub it into the original. The absolute value of 3 times 2 minus 2 plus 8 is supposed to give us 12. Inside those absolute value signs, we get 4 when we do all of that multiplication and subtraction. So we have the absolute value of 4 plus 8 The absolute value of 4 is 4. So 4 plus 8 gives us 12, and 12 equals 12. So that checks. We should probably put question marks up above those. That checks, which means that x equals 2 is the solution. The other check that we're going to do is the absolute value of 3 times negative 2/3 minus 2 plus 8 equals 12. And that means as we go through and check this, we'll end up with the absolute value of, when we multiply 3 times negative 2/3, we get negative 2 minus 2. So this is the absolute value of negative 4 plus 8 equals 12. Absolute value of negative 4 is 4 plus 8 equals 12. We should put our question marks again. And then we end up with 12 equals 12. So that checks as well. So this is also a solution. We end up with two different solutions. We could write them in these funky brackets. Negative 2/3 and 2 would be our solution set. So it's safe for me to say that you have to go through and do the check, whether you do it mentally or you do it on your paper. It's got to be done. Otherwise, you could give me answers that actually would have been eliminated. In example B, the two scenarios are going to end up to be, now this one already has the absolute value sign isolated on the left-hand side. So our two scenarios are going to turn out to be x plus 10 equals 4x minus 8, and x plus 10 equals the opposite of 4x minus 8. Whoops. No parentheses, no absolute value. When I go to solve this, same kind of thing. Solve for x. So we get negative 3x equals negative 18, and x will be equal to 6. And here we're going to end up with, we've got to distribute that negative on the right-hand side, and it becomes negative 4x plus 8. And when we solve for x, we'll have 5x equals 18. No, that's not right, is it? Did I do that right? Oh, this is x minus 10. So it should be 5x equals, negative 2, and x will be equal to negative 2/5. We're going to substitute both of them in. I'm going to do this a little bit more as a mental substitution. So 6 plus 10 on the left-hand side is 16. The absolute value of 16 is 16. And 4 times 6 is 24 minus 8. That gives us 16. So this one checks. This one's good. Negative 2/5, if we sub negative 2/5, negative 2/5 plus 10 is 48/5, because 10 is the same as 50/5. The absolute value of 48/5 is 48/5. 4 times negative 2/5 is negative 8/5. Minus 8, which is negative 40/5, brings us to negative 48/5. So here I end up with positive 48/5 equals negative 48/5. That doesn't check, so this answer goes out. In this case, we only have one acceptable answer, which is the solution set of 6. Here we got 2, here we only get 1. I'm going to give you one more concrete example and then one that's a little bit of a real world situation. The last concrete one is the following. Solve the absolute value of 4b plus 1 plus 3 equals 0. We want to isolate this part where the absolute value is, and that becomes 4b plus 1 inside the absolute value signs equals negative 3. Now, I've been paying pretty close attention to what I've been saying about absolute value and the definition of it. We said that every absolute value should be evaluated to equal a positive number. Well, look what this is saying. This says that this absolute value has to equal a negative value. That can't ever happen. So as soon as I recognize that, I can say that this actually holds no solution. We name that solution set as the null set. It's a 0 with a slash through it. So if you recognize that, you can stop right there. If you don't, what would happen is you would write your two scenarios. 4b minus 1 equals negative 3, and 4b minus 1 equals positive 3 and solve those, and check both of those solutions, and you would find that that's something that we may talk about in class if someone has a question about it. So that's the last of the concrete examples. The last one that I have for you is a little bit more of a real world situation. And it reads this. You tennis players are going to like this one. It reads, a standard adult tennis racket has a 100 square inch head. So we'll find a couple of important pieces here. 100 square inch head plus or minus 20 square inches. So that means we can go 20 above or 20 below. Our job is to write and solve an equation that has an absolute value in it to determine the least and greatest possible sizes for the head of an adult tennis racket. Now, I think you can probably do this in your head as far as what the answer should be, but we're going to actually apply the algebra and the concept of absolute value to it in order to demonstrate our answer. So to do that, I'm going to give you a formula, and this formula is going to say, this is horrible as far as the writing, I apologize. The absolute value of x minus c is equal to r. C is called the central value. That's going to be the number that really is in the center of everything. The R is considered to be the range. So in this situation, let me switch colors again, we end up with this as our formula. The absolute value of x minus that central value. So is 100 or 20 the central value in this case? If you chose 100, you're correct. Equals the range value of 20. So this is the absolute value. This is the first part of what we want to do up here. We're going to solve it now by writing our two scenarios. X minus 100 equals 20, and x minus 100 equals negative 20. And that's going to lead us to solutions that are positive 120 and 80. If you mentally check those, 120 minus 100 is 20. The absolute value of that is 20. 20 equals 20. 80 minus 100 is negative 20, but the absolute value is positive 20. So 20 equals 20. They both check. So you're going to tell me in order to answer this that the least size is going to be 80 square inches, and the greatest is going to be 120 square inches. So that would be what I would look for this work. I would be looking for the equation, I would be looking for the solution, and I would be looking for a final answer. So let me know if you have any questions about that. That's the basic gist of solving absolute value equations. We're going to do quite a few examples with dealing with those when you come into class, when I see you next. So make sure you come in with any questions so we can sort that out before we actually do start the problems. Thanks for listening.